Hello, welcome. In this video, we're going to talk about recursive functions and to use recursive functions to manipulate a linked list as a demonstration. And then you can go away to work out the program using recursive function to manipulate a tree. First, let's have a look at the demonstration. Okay, in this program, after started loading, and it has created objects n1, n2, n3, n4, n5, n6. 6 nodes. Okay, here are the initial values. n1 initial value is the element name is node is made and pointers now. Again, n2 same. A node is made, a node is made, or now pointers. Can you explain why that is the pattern? You need to think about the constructor. What is in the constructor? Yeah, correct. That's because in the constructor, I have made the initial values as, that's the constructor. The initial values of the two attributes of properties, one is node is made and one pointer is null, exactly as it is shown here. Okay, so a constructor is called to make this. That is call from the constructor. Okay, new node, to make the new node and assign it to n1. Therefore, n1 is the first node. Okay, that's the tracing of its properties. And then n2, same way, up to n6. Okay, that's the initial values of them. Then I started changing them, setting the value, calling them setters. Okay, so here it says n1 name and point has been changed. N2, so is N3, N4, N5. N6, a name is being changed, but pointer is not changed. Therefore, its pointer it stays as now, but name is changed to something else. Let's find out what's being changed to. Okay, now click on this button here. That's the new printout. This is to show the findings of the recursive function call. First, level 1, you find number 1 is object node type. And then you went to number 2, level 2, find number 2. Okay, and level 3, number 3, level 4, number 4, level 5, level 6. I have reached the end. How does it know it's reached the end? And we know it's level 6, and the number 6 is the name of the element. Okay, it's the same as this one. See, that's n1, n2, and so on, n6. n6 pointer point nothing. Everyone else pointing to the next one. Okay, so how does the recursive call work? Okay, let's go back to the code. Now, I've made the objects. I've changed them so that they become the linked list. Yeah, all you need to do is to set the pointers so they can link to each other. Okay, and change the name as well, you can. Now, that's the listener for the button to work. When the button works, you say, all right, I start listing the findings of the function call. Then you call the function. That is the function, first function call, calling find number of elements in that list, starting with the root n1. Okay, and then say this call is made, so all the program execution will go to this section. Now run this section. Once this section is run, finished, we'll go back to there, carry on, finish off the rest. Okay, so this one is the one we are talking about. That is the function we call recursive function. Why? That's the name you defined the function, and inside of the function you are calling yourself. That makes it recursive call. Calling yourself in the function is a recursive call. But for it to work, you have to define the base condition. That is when you don't need to call anyone else, just simply return yes because I know the results. Okay? Okay, so that's the condition. What is the condition here? Is the list. When you reach the end of the list where the pointer would be now. So when you see a now pointer, that means you know it's the end of the queue, the list. So therefore, you take that as a base condition. If the pointer is now, then you say, I have reached the end, and do the counting of the level and trace the name of this and trace the level you've reached. Okay. If it's not now, means you got more elements. Therefore, you need to call your function again to find out how many more elements are there. So when you call this one, the parameter you passed in is different from the one. That's the root. Now is the root pointer. The one the pointer is pointing at becomes the first element. So because you are one level down. Okay. Define the function, define the base condition, and call this one. All the rest are the business logic. You decide to count how many levels, or you decide to show the name of the element you are visiting at the moment. That's all down to you. Okay. Here I've counted the level, number of levels I've gone down to. Then trace the level to show on screen, and then show the name of the nodes you are visiting at the moment. And this one is showing whether the pointer is pointing at anything. Okay. Okay, that's the quick demonstration. Now I'm going to show you the nodes definition, because we've been using nodes to demonstrate. Okay, that is the class definition for node. Public class node, declaration of the class, two properties or two attributes, one constructor. One constructor makes the initial values assigned to the properties. And then you've got two setters, set name, pass on a variable, a value, set pointer, pass on a value, and two getters get the results to return to you, so you can use it to display or to add, to manipulate. Okay, that's the node definition. Now your task is to define a node for a tree. That means that node would have two pointers, left and right pointer. And then you can use that node to make your tree. The tree would have 10 elements holding numbers 1, 2, 3, up to 10. Okay. The first node for the tree, the root of the tree, would be number 5. Okay. And then you can enter randomly any number you want.